Good morning, everyone. Welcome to the video lecture on wireless cellular and 4G LTE, module number 5, lecture number 8 on mobility management, part 2. In this particular mobility management, today we will see what is the impact of intercellular interferences coordination, okay, or basically we call it as ICI, which is called as intercell interferences, okay. So what are the various interferences which are being inculcated in this particular LTE system, especially in terms of mobility management? If there is some kind of mobility, that is switching off your cell phone user equipment from one cell to another cell, and the utilization, that is nothing but frequency reuse mechanism. If I try to make use of frequency reuse mechanism, then what will be the impact of that particular movement or mobility of that user equipment or the mobile user from one cell to another cell, and is there any kind of loss in the spectrum efficiency? So therefore, in mobility management, what is the importance of intercell interferences with respect to the downlink and uplink channels? So therefore, looking into the consideration of this intercell interferences, basically what happens is, here in intercell interference we simply call it as ICI. The concept of frequency reuse mechanisms, which has been an important factor in the conventional cellular system, okay, and where this was possible, which has made possible to increase the spectrum, okay, by lowering the frequency reuse or simply increasing the average loading per cell. For example, if the number of subscribers are more in one cell, which is of hexagonal cell, and if I want to limit my ICI, okay, due to frequency reuse mechanism, then the spectrum efficiency will automatically was increasing, okay, due to the frequency reuse mechanism. But this problem will not be similar, or this concept will not be similar in LTE. This was only useful in conventional cellular network like your 1G, 2G, 3G, okay. It was possible, but now it is not possible in LTE system. Therefore, just to meet the problems of spectrum efficiency, okay, so what this LTE will do is, LTE will deploy the universal frequency reuse mechanism, okay. That is nothing but the same spectrum, okay. For example, if I have a spectrum of 2 gigahertz, and that particular 2 gigahertz will be reused in each cell. For example, if I have some 10 cells, it means that all the 10 cells will be using the same frequency use mechanism, irrespective of their cell area, irrespective of their geographical area. So therefore, if I make use of this particular mechanism, then there will be a huge high level of intercell interferences, okay. So therefore, just to overcome the problem of high level of ICI, okay, there are some user equipments are there at the cell edges, okay. For example, if you have the hexagonal area, okay, and if you want to go for the measuring of your frequency cell reuse mechanism, then when you consider the particular cell, okay, and that cell will be having its edge, we call it as edge, okay. So therefore this concept of frequency reuse mechanism will be at very high level, okay. Therefore this LTE will have some kind of mandatory mechanism, such that there will be an increase in the cell edge throughput, okay. And the ICI control techniques must be applied, okay. Where it should be applied, it should be applied both in the downlink as well as uplink transmission, okay. Now we will see how this ICI will be reduced in uplink and downlink mechanisms. And if you want to reduce the intercell interferences, then what are the basic approaches you need to follow during the downlink as well as in the uplink, okay. So let us look first into the downlink mechanism, okay. So it is also called as the approaches required for magitated ICI, okay. So basically in downlink we have 3 approaches, okay. So the first approach here is ICI randomization, okay. So always remember, the concept of ICI says that there should be reduced in the level of intercell interferences, or simply you can call it as the kind of a distortion or a noise. It should not be mixed, it should not be mingled with one cell to another cell. Okay, so how you can minimize this interferences is by making use of ICI randomization. And what is this ICI randomization? This ICI randomization is nothing but the scrambling of the code word after channel coding. For example, if there is one transmitter and I'm transmitting my signal from one cell to another cell, okay, during the channel part, okay, when it comes to the channel part or before transmission, what we do is we do some kind of coding. Okay, and you need to not, you should not send only the normal code, you should scramble the code. Scramble in the sense you should make some mixing of code or randomly generating some number. Okay, and here the mechanism is nothing but pseudo random sequences. Okay, so therefore if you scramble the code, or we call it, or the channel code, what happens here is the cell's specific scrambling, that is the ICI from the neighboring cell, is randomized. Okay, for example, if all the cells are interconnected with each other with their cell boundaries, okay, and when you do that at the some specific areas of the cell, or you can call it as simply the neighboring cells, okay, if it is randomized, how it is randomized? By scrambling. Okay, and then the interference suppression is achieved. So if you try to go for the randomization or the scrambling of code word, then you may achieve the suppression of interferences. Okay, and how, what in turn this will do? This will do the gain, which is that is nothing but the processing gain which is being achieved here is nothing but it's a better by the channel code. Okay, and what happens if you do not scramble? Okay, if you do not scramble, if you want to transmit your the same data, that is if you want to go for download of the same data without any scrambling at the channel coding, then if you do without scrambling, the channel decoder might be equally matched to interference signal as to the desired signal on the same radio resources. Okay, so that is the problem here. So therefore better go for scrambling of data, because if you do not scramble, then by making use of some decoder, I may go for matching. Okay, the signal gets matched, then there is a problem again. Okay, because of because it may match, because we have the different codes which is entering it to the receiver side. Okay, so that problem that becomes a bit problem. Okay, so therefore always go for scrambling of your data or scrambling of your code. And the ICI randomization has been applied in the system such as universal mode of telecommunication services. Okay, so first step was randomization. The second thing is you need to cancel. We call it as a ICI cancellation. And how you go for ICI cancellation here is, if you have a user mobile, okay, which is able to decode the interference signals. Okay, you know the concept of the noise cancellation. Okay, many of the electronic devices like your microphone and the speakers, sometimes they come with the echo cancellation, okay, noise cancellation. Okay, same thing here also. Okay, so if you have a user equipment which is able to decode the interference signal, for example, already the signal which you have downloaded, it is a noisy signal or it is an interference signal. Okay, and if you are able to decode, okay, you are decoding, and if you are able to regenerate, okay, regenerate the actual signal or regenerate the original signal. And how this can be done? One is the original signal and another is nothing but the decoded version of your original signal. Okay, and then you simply subtract both. Okay, if you subtract both from the desired signal, then you may achieve the exact data or exact signal. Okay, with a multi-user detector. Instead of using one detector, you may go for more than one detector. Okay, because what happens is, if you use one detector at one particular time, it may not detect the interference signal. Okay, if you use the multi-detector, there is a possibility that at different time intervals the detector may detect the code and it may go for subtraction, but so that the desired signal can be obtained for that particular user equipment. Okay, now if you making use of that decoder for the interference signal from the neighboring cell, okay, then you need to know its transmission format, obviously, right? For decoding, you need to know the transmission format, not the reception format. Okay, because transmitter is using one format and then it will transmit the data. If you do not know the transmitted format or what the transmitter is making use of the format, then you may not be able to decode it properly. So therefore it is mandatory to know the transmission format before decoding from the neighboring cell also. Okay, now the alternate mechanism what you can do for the ICI cancellation here is the ICI cancellation can be performed in the spatial domain. Okay, so what we have seen, we have different types of domain, right? We have time domain, we have the frequency domain, right? We have some spatial domains, okay, where we make use of some coordinate system, and then we try to go for the measuring its performance. Okay, and always the performance of what we do, or this performance which is achieved in the spatial domains are far better than the other domains. Okay, so that is why we go for spatial domain, and LTE make use of spatial domain rather than other domains. Okay, so therefore the ICI cancellation can also be performed in spatial domain. Okay, and how this can be done? By making use of some spatial linear spatial interference cancellation. Okay, and by making use of some statistical knowledge, okay, such that the ICI cancellation can be achieved, or at least it can be limited. Okay, when you go for downloading the data, if you download the data with some kind of additional interferences, then it becomes a problem. So therefore, instead of downloading the whole complete data of the interference signal, try to limit the interference signal by making use of ICI cancellation. Either you can use the ICI cancellation, or you can go for some multi-user decoders, or you can simply go for ICI randomization. Okay, so this is the second approach. The third approach here is, it is ICI coordination, or simply you can call as avoid. Okay, so now how we can avoid the ICI? This can be achieved by putting some kind of restrictions in the downlink resource management. Okay, what do you mean by the restriction here is, for example, if you want to receive the signal only till 1 gigahertz of frequency. Okay, I don't want my signal, I don't want a signal which is beyond 1 gigahertz. So what I will do, I will put some kind of limiters, okay, at the downloading part. It will not receive, it will not accept the data which is beyond 1 gigahertz of frequency. Okay, so therefore I can avoid in this fashion. So therefore if you make use of ICI avoidance, this can be only done by applying some kind of restriction at the downloading resource management. Okay, and this, how this can be done? In a coordinated way between the neighboring cells. You should coordinate with the neighboring cells, okay, such that, how to coordinate with the different neighboring cells? The term coordinate means that, for example, if you want to receive some information, if you want to download some information from some neighboring cell, so you should coordinate, you should tell the neighboring cell that I am only able to receive the data which is up to 1 gigahertz or less than 1 gigahertz. So do not send me the data which is more than 1 gigahertz, beyond 1 gigahertz. So if the neighboring cell transfers the data which is less than 1 gigahertz, then automatically I can receive the proper data. If it goes beyond 1 gigahertz, it will be considered as some kind of interferences. Okay, so therefore where you can apply the restriction, the restrictions can be on, it can be in terms of time resources, or it can be on the frequency resources, or in terms of transmitter power. Okay, that is what it will be only from the transmitter. You need to inform the transmitter that do not send me the data which is having the more power. It should be of limited power, so that I can handle it into the proper way. Okay, so in this way the ICI coordination can be achieved. Okay, so based on some kind of requirement, or based on some kind of some static, semi-static, or the either static, okay, requirement, we do have some kind of different requirements based on some different performances. Okay, so the two performance here, what we can see here is, one is called a static ICI coordination or avoidance. Okay, another is semi-static ICI coordination avoidance. These two categories will fall under this ICI coordination avoidance. Okay, so one is static, another is called as a semi-static. So what is static here is, this is mainly done during the cell planning process. Okay, at the beginning only we do this. When you go for planning, or when you go for designing one particular cell area, okay, you need to do this kind of static coordination. Okay, and this process do not require any frequency reconfiguration. Frequently reconfiguration is not required. Once configured, that's it, it is done. Do not go for doing it again and again and again. Okay, so therefore this is fall under the category of static coordination. Okay, and this static coordination strategy, it requires or a little kind of internode signaling process. Okay, but there is a performance limitation as dynamic characters such as cell loading, okay, user distribution are not taken into the consideration. So we do have some kind of limitation with this static coordination. Okay, like we do not go for cell loading. Okay, we cannot go for user distribution. Okay, so this is one problem here. So the similarly when you come to the semi-static, okay, so semi-static coordination, they are typically requires reconfiguration. Okay, for example, if I have used my device by configuring it at some time interval t, then if somebody want to utilize that particular device, then he need to reconfigure again. One more configuration is required. So it is based on the time scale. Okay, that is what they have said, time scale, in the sense at time t1 somebody will use and reconfigure, at time t2, okay, already it is reconfigured, but still he has to reconfigure. Okay, again and again, it's a time scale based on the order, okay, based on the seconds, okay, or sometimes it can be longer, or it can be an inter-e-node communication over x2 interface. Okay, and the information which has been exchanged between these two nodes, okay, these two cells, can be in terms of your transmission power, or sometimes it can be based on your traffic, okay, traffic load on different resource blocks. Okay, so therefore by considering this such information like the traffic node, or sometimes the transmission power, okay, at the neighboring e-node base, ICI separation is more efficient. Okay, so in this way we go for the downlink three approaches, which are the three magitated ICI approaches we call. Okay, so whenever the question is asked based on the downlink, explain the three basic approaches. So you explain what is randomization, what is ICI cancellation, okay, and then ICI coordination or avoidance. In that particular, you also explain what is static and semi-static coordination or avoidances. Okay, now based on the coordinates, okay, we have some topic here called as a multi-point transmission. Okay, you can see there are three figures here, they are all possible downloading power levels. Okay, you can see frequency versus power. At this level we do have high power, and at this time interval we do have the same power. This is with respect to cell 1. When you go at look into the cell 2, the power at this time is more than compared to other times, and at the some other levels the power at cell 3 is more here than compared to these levels. So it says that if you are using three neighboring cells which are attached to each other, and when you measure the cell edges, okay, how this can be allocated in terms of power: one cell, two cell, and three cell. Okay, and what it says that if you are making use of some advanced LTE mechanism, and if you want to improve the performance of cell edge performance, we are not speaking about the cell core performance, we only speak about the edge performance. Okay, so edge performance, some advanced techniques are being used, okay, such that the ICI can be limited. Okay, so one of the technique here where we can go for the improving the cell performance is nothing but it is called as coordinated multi-point transmission, or it can be reception. Okay, so basically in downloading, or in terms of downloading downlink coordinated multi-point transmission, it makes use of some kind of dynamic coordination among some multiple geographical separated transmission points. Okay, and how they can be deployed, how they can be deployed in the form of coordinated schedules, or by making use of some beam forming. Okay, or it can be in terms of multi-cell joint transmission. Okay, in this way they go for having achieving the better noise cancellation. Okay, they can go for the cell interference avoidance, they can go for cell interference cancellation, or sometimes they can go for cell interference avoidance or cell interference randomization. So in this way they try to go for limiting the power levels based on the users or based on the cells. Okay, now whatever we have seen in the uplink, the same scenario will fall under the category of downloading also. Okay, so what we do here in downloading are, again we have some kind of basic approaches, okay, related to uplink. So again ICR randomization, cancellation, okay, then avoidance. The extra part here is uplink power control. So what is randomization? It is almost similar to downlink. We go for scrambling of our coding, channel coding. okay, but not in terms of downlink, we do in the uplink. Okay, so whatever the explanation what we have seen above, where this can be achieved by scrambling the encoded symbol, not decoded symbol, and where you need to go for encoding before transmission, before modulation. Okay, now instead of cell specific scrambling which is used in the downlink, here we go for user entity, user equipment, cell specific scrambling which is used in the uplink. Okay, as you can see, the ICI comes from multiple user entities in the neighboring cells, because the neighboring cell may have more than one number of subscribers. Okay, so if they are coming into the our neighboring cell subscribers, it becomes multiple. Okay, now if multiple users are coming to that particular cell area, then you need to go for ICI randomization before they are downloaded. Okay, now similarly to the ICI cancellation, here the ICI cancellation, it is more applicable in uplink rather than in downlink. Okay, because downloading is not more important than that of uploading, because if your uploaded data is not itself proper, then you will receive the downloaded data in a incorrect manner. Okay, so therefore this ICI cancellation, it will be more applicable, it will be more advantageous in the uplink rather than the downlink. Okay, and how this can be done, as you can see, higher computational capability and usually more antenna elements are used. So here the concept of multiple antennas or the array of antennas comes. If you have more than one antenna, then you may go for achieving the high cancellation during the uplink only. Okay, so this is one scenario. Then what is uplink power control? So the power control is then again the efficient way to suppress the ICI. If you are making use of the huge power for the uploading itself, then it becomes a kind of cell interference. It becomes a kind of interferences. Okay, so rather than using of the more power, try to make use of fractional power control. Okay, which is used basically in LTE system. Now the last here is ICI coordination, which is nothing but it is again a similar technique which we have seen in the above, that is static and semi-static technique. Okay, and here if you want to go for the uplink coordination or the avoidance, here you can see is the uplink ICI coordination. Here the two messages are defined. Okay, so that can be exchanged by making use of your X2 interfaces. Okay, similarly for the power allocation, and you can even go for the scheduling. Okay, and if you do such kind of the cancellation, if you try to go for the avoidance, okay, so you may come across the high interference indicator. Okay, or sometimes it is called as interference overload indicator. Okay, and this is usually done at the physical layer measurement when you go for uplink interferences, where there will be some kind of noise. Okay, which is based on some kind of power suppression techniques. Okay, which will help you to limit the power, to limit the interferences before uploading into the channel or before uploading it towards the receiver side. Okay, now what we have seen again here in the downloading is nothing but the coordinate multi-point transmission there. Okay, sorry, coordinate multi-point transmission in downloading. Then here we may have coordinate multi-point reception. And how this can be done? Again, it is almost similar to the downloading, where we make use of some kind of the spatial coordinates. Okay, and some kind of advanced LTE uplink channels. Okay, and with this particular multi-point reception, you may also make use of some multi-point nodes. Instead of one node, you may go for multi-point node, where the transmitted signal or from multiple geographical separated user entities in different cells can be used. Okay, again with respect to the downloading, here the uplinks coordinate multi-point reception is expected to be very limited. Okay, you cannot go for very high impact, so instead of that you go for limited capacity, so that you can even have with better efficiency with this particular radio interference specification. Okay, so therefore if you want to go for the reduce in the ICI with respect to the downloading and uplink, you have to go for utilizing all these approaches, such that any interferences with respect to the uplink and downloading can be minimized as much as possible, such that the LT will give a better performance than compared to the conventional type of other wireless communication or wireless cellular aspects. Okay, so with this the module number 3 is completed. Thank you.